All right, class, in this lesson we're going to take a look at section 3.3, and that's dealing with the conditional and biconditional for truth statements. So let's take a look. We've got the conditional, which says that in order to understand when a condition is true or false, we've got to take a look at this example. We've got Mr. Gates, the owner of a small factory, has a rush order that must be filled by next Monday, and he approaches you with his generous offer. He says, if you work for me on Saturday, then I'll give you a $100 bonus. Sounds pretty good, right? So, let's talk about this in cases as far as the conditional goes. So, case one, W is true, and we're going to call W as work, and then B is true, so we're talking about the bonus. So, case one, you come to work and you receive a bonus. Okay, so W is work, B is bonus. So, you come to work, you get the bonus. So, case one would have to be true. Case two, so W could be true and B is false. So, you come to work and you don't receive a bonus. Now notice what we just did was we took the statement that he promised and we're saying, well, it could be true, it could be false. Conditional is true or false. So it doesn't mean that we're actually going to get this. We're working for me on Sunday and I'll give you a $100 bonus. Well, he could have just been blowing steam or blowing smoke and maybe he wasn't being truthful when he said this. So the conditional way of looking at it in math is to understand it that this is the possibility. You come to work and you don't get your bonus. Or the third thing could happen. You could not come to work, but he gives you the bonus anyway. Why would that happen? Well, maybe he felt like it. This is what he said. He didn't say, I won't give you a bonus if you don't come to work. He says, if you do come to work for me, I'll give you a bonus. Well, it could be the other way around. Maybe I don't come to work and he gives me a bonus anyway. And finally, number four, you don't come to work and you don't receive the bonus. This is what we would all expect to happen, but again, it's not about expectations here. It's just about whether or not simply the way that the truth itself works out in these conditional statements. So the way that this works is that if both statements are true, then we get true. So the P then Q thing happening from last lesson. If the first one's true, the second one's false, then we're going to get a false statement. Okay, but if we have false and true, then what we actually get here is a true statement. So this is a little bit different than our ands from before, because this is truth in that it actually happens. Because the way that these conditionals work is that the statement is false only when the hypothesis is true. So like here are the only places where it's possible for them to make a false statement, and the conclusion is then false. So if the hypothesis is true and the conclusion turns out false, that's where you get a false statement. Notice here we've got a true statement and true, we get true. This was false to begin with, so the conclusion, it doesn't matter. You're going to get a true statement because the hypothesis was false in the beginning. Okay, so let's continue to take a look at how this plays itself out. So our definition right here is that for the P then Q statement, P is called the hypothesis and Q is the conclusion. P is the first thing, it's the hypothesis, Q is the conclusion. So we can derive the following statements from this conditional P, if P then Q. So the converse is you take the Q and the P and you replace them. You switch the order. In other words, you put the conclusion first, then the hypothesis. The inverse takes it the way that it was, and it says not P, then not Q. And then contrapositive, it takes and it's basically taking the inverse of the converse. So I said that inverse of the converse. So here's the converse here. If you notice, I take and switch both of their signs. That's finding the inverse, which is taking the not of both of them, of the converse, the traded place. Okay, so hopefully this table down here helps us know what to do. And then I said this, but here it is in words. So the conditional is the statement. Converse, you just switch the P and the Q, switch their places. That's what's happening up here. And then inverse is negating P and Q. You don't switch them. And then negate P and Q and also switch is the contrapositive. So we're going to try to work through this a little bit in some examples here. Back to this conversation about the converse, inverse, and contrapositive of the marijuana is legalized, then the drug will abuse will increase. The if gives you the hypothesis. The then, whatever follows, is the conclusion. So down here on your phrases, this would be the P, then Q. So that's the standard way that we want it. And so we just want the converse. The converse says to just switch P and Q. So basically we would say if the drug abuse will increase. So if we said if this, then marijuana would be legalized. So that actually looks like this. If drug abuse will increase, then marijuana is legalized. You can see that these are just trading places. Okay. The next thing it asks us to do is find the inverse. And so to find the inverse, that, just down here at the bottom, you can see that it negates both P and Q. You don't switch them. So we would just negate the if. So if marijuana is not legalized, then drug abuse will not increase, is what the inverse will look like. And you can see here, if marijuana is not legalized, then drug abuse will not increase. Okay, let's clean this up. So the last one asks us to do the contrapositive, and so the contrapositive says negate both and then also switch. So we're going to say if here drug abuse will not increase, so that'll be our first phrase, and then we'll put that out in front. And then marijuana is not legalized or will not be legalized. So that'll come down over here. So you can see that that's how this is written. If drug abuse will not increase, then marijuana is not legalized. Okay. So now we'll take a look at these statements here. Up at the top, you can see we're asking the question now basically about our the original statement, the inverse, the converse, and then inverse. So converse here, this is the inverse, and then contrapositive. And we want to know which one's logically equivalent. So here we'll take a look at this statement here. We're going to use the contrapositive to rewrite the following statements. If you pay a deposit, then we will hold your concert ticket. So the contrapositive says negate and switch. So we're saying if we will not hold your ticket, so that's going to go right here, then you will not pay a deposit. So you can hear that the way that it sounds. If you pay a deposit, then we will hold your concert tickets. You can hear it the other way. If we do not hold your concert tickets, then you will not pay a deposit. So you can hear it working out and it sounding the same way. So this is the original statement. Let me erase this. Sorry, I got a lot going on here. Original statement and contrapositive are equivalent statements. Okay? So they're saying basically the same thing, logically equivalent. Okay. So now the next one, if you do not itemize, then you will take the standard deduction. Notice the negation here. So there's a negation, which is one of our ones up top. We've got a negation here. And then you take the standard deduction. So the way that we've got this is the negation goes to the S. So if you do not itemize, then the S is our standard deduction. Then you will not take the standard deduction. The contrapositive switches these. So we say change that and put the not over here. You would not, right here, would not take the standard deduction. So we say if this, then over here you would itemize. So if you do not take the standard deduction, then you'll itemize. So let's take a look at the actual notation. So that's the not here of the original statement, the not of the hypothesis, then the conclusion. So when you trade places here, you would get the not of the conclusion and then the original hypothesis. So these are equivalent statements here. If you do not take the standard deduction, then you will itemize. So if you take the original statement and find the contrapositive, you'll get logically equivalent statements, is what this is working through. So basically, here to there. And now notice this is still just a original statement. It's just the original statement happens to have a negation in it. and when you trade places, the negation trades places for the letter B. Right. Now, last, this is one that I stole as an example from your homework. It says that you're going to rewrite the statement using the if-then connective. All that means is write an if-then statement. So you're going to rearrange the wording or add words as necessary. So the nice thing about this is you already have an if. So that means what follows is, I can't draw straight apparently. You have if, and then this is the hypothesis. Okay? The rest of it would have been your conclusion, and it needs to go at the end. Okay? So we've got, if you see it on the internet, then you can have it. Now notice the original statement says, you can have it if you see it on the internet. Well, that's a regular phrase that you would say, talking to a friend, but in a math organized statement structured, you need to say, if you see it on the internet, this part, comma, then you can have it. Okay? So that is how you would organize it, and I'm going to save you the burden of seeing my actual chicken scratch, but follow my arrows, please, to put that in the order. So that's how you would organize that structure, and again, please continue to email me with any questions you may have.